Hi, so for today we're going to talk about coefficients linear in two variables. This is still a part of the differential equation video. But before that, bumabati lang ako ng shoutout. No? Shoutout ko lang si Marion Bell, BS Chemistry, second year student from the Central Mindanao University. Hi there, Marion. So ito na yung video na ni-request ninyo. And God bless on your finals this first week ng December. So this is tutorial video na ni-request ninyo. So, let's get started. So, coefficients linear in two variables for differential equation. So, suppose that we have a differential equation in the form of this equation. We have a sub 1x plus b sub 1y plus c sub 1 multiplied by dx plus quantity a sub 2x plus b sub 2y plus c dy is equal to 0. So, if we have this form of differential equation, okay, we have a linear in two variables. So, for the previous discussion of homogeneous differential equation, that is only linear in one variable. Okay, but in this case, linear in two variables. So, if you might notice here, okay, A, B, and C are constants. So, if you may notice here that this quantity or term represents a line. Okay, if you put it equal to 0, and this second term here with the dy together with the dy represent also a line. Okay, so what will happen here is that if the lines intersect, okay, if the given lines here in our dx and dy intersect at hk, where h and k are points of intersection of that line, we will use a substitution. Let x is equals to u plus h, where h is actually the x coordinate of the point of the intersection, and we're going to let y is equals to v plus k, where k is the y coordinate of the point of intersection. Okay? But if the lines are parallel, meaning if we have a parallel line, their a sub 1, their a, b, okay, constants are the same. Okay, so for example, let us just recall 2x plus 3y minus 1 is equals to 0, and we have 2x plus 3y plus 10 are parallel lines because the a here is 2, a here is 2, again, b here is 3, and b sub 2 is 3. So the only difference is in the terms of c sub 1 and c sub 2. But if they have the same a and b's, okay, they are parallel. So if they are parallel, we will be using this substitution. Let b is equals to ax sub 1 plus b times y sub 1, or ax sub 2 plus by sub 2, or simply, okay, or simply we are going to use ax plus by. Okay, so we will be using that since the b sub 1 and b sub 2, okay, a sub 2 are all equal. Okay, my mistake. This should be I'm sorry, this should be a sub 1, a sub 2, and we don't have x sub 1, x sub 2 here because that's the same x. Okay, so let me just correct that. So we have a sub 1 x, a sub 2 x, b sub 1 y, b sub 2 y. Or in other words, we can use a, okay, x plus by in our substitution. Okay, let's get started. For this video, I'm going to show you two examples only because it's very, it has a long solution. Okay, so for number one, let's solve the equation x plus 2y minus 4 quantity dx minus 2x plus y minus 5 dy is equal to 0. Now, let's check the lines. So we have x plus 2y minus 4 is equal to 0, 2x plus y, okay, minus 5 is equals to 0. Okay, so we can see here from this lines, okay, from here and here, we can see this that this is not parallel, okay, not parallel. Okay, so what are we going to do is we are going to find the intersection of this. How do we find the intersection of that? Well, simply we can use substitution. Okay, from equation 1, we substitute this on our equation 2. We have 2 times 4 minus 2y, okay, plus y minus 5 is equal to 0. And then solve for the value of y, okay? And we have negative 4y plus y minus 5 is equals to 0. So if we're going to solve for that, we have 8 minus 5 is 3. Okay, so 3 minus negative 4y plus y is negative, that's already negative 3y is equals to 0. So what will happen upon solving the y, we have y is equals to 1, okay? Or that is the point of intersection, so this is equivalent to our value of k. And if we know the value of k already, which is equal to 1, or y, which is equal to 1, we can substitute it, okay, in our first equation or any of the equations. So we have the value of y, x plus 2 times 1 minus 4 is equal to 0. So we have x plus, we have 2 minus 4 is negative 2. Transpose it on the right side, we have x is equals to 2. So the point of intersection x, okay, hk, 2 and 1. So this would be our h and this would be our k. That's the point of their intersection. They are not parallel, so hence they will intersect at some point, and this is the point of intersection. And from the previous formula, we have to let, again, x is equals to u plus h. We have y is equals to v plus k. Okay? The point of intersection is 2, 1, wherein this is our h and this is our k. So if we're going to substitute that, we have x, u plus 2. We have y is equals to v plus 1. Okay? And we're going to get the derivative of that. Okay? Dx, derivative is dx, and that is equivalent to du. Because if you're going to get a derivative of this with respect to x, on the left side, that's dx. With respect to u, that's only du. The derivative of a constant is 0. So we have the y, that is dy, okay, is equal to a dv. So we will use this substitution for our differential equation. Okay? So what will happen is this. So we have the given equation x plus 2y minus 4 dx minus 2x plus y minus 5 dy. We simply substitute the value of x and y and dx and dy here. So what will happen for the x? We have u plus 2, that's the x, plus 2, which is y, which is v plus 1, minus 4, multiplied by dx, which is now equivalent to du. Okay? Minus 2 times x, which is u plus 2. Okay, let me just rewrite this neatly. Okay? So we have minus 2 times the x, which is u plus 2. Okay? Plus v plus 1, that's the y. Okay, here. Minus 5. And we have the dy is now simply equal to dv, which is equal to 0. So what I'm going to do is to perform algebra. So we have u plus 2 plus 2v plus 2. Okay, minus 4. We have du here. Minus 2u plus 4 plus v plus 1. Minus 5. We have dv is equals to 0. Upon simplifying this, we'll be having u. Okay. 2 plus 2 is 4. This plus this is 4. Minus 4 is simply 0. So we are left with u plus 2v here, multiplied by du, minus we have 2u plus v, okay, and we have 4 plus 1, this one and this one, 4 plus 1 is 5, minus 5 is simply 0, so we have dv is equals to 0. So as we can see here, this is reduced to a homogeneous, okay, applying the homogeneous formula. Simple formula, u plus 2v, let me just rewrite, du, minus 2u plus v, and we have dv is equal to 0. So we have reduced this into a simple homogeneous dE. So, did you still remember the homogeneous differential equation when we try to substitute x is equals to vy and or y is equals to vx? So what are we going to do here is we are going to let, okay, let u is equals to vz, where z is the added variable again, And of course, okay, we can get the derivative of u. So we have du is now equal to product rule v dj, this first and derivative of this plus copy this z, then derivative of the first term. So we have u is equal to vj, du is equal to v dj plus z dv. Again, this simple substitution is the one that we did on the homogeneous differential equation. It's such that it happened that the variable here is now z and the variable is u. Okay, in the previous video we have let b is equals to x, let y is equals to bx, let x is equals to xb. Okay, if you're going to remember that. So if we substitute that, we have bz plus 2v, okay, is now equal to du, which is v dz plus z dv minus 2 times the u, which is vz, which is simply 2vz plus v multiplied by dv, simply dv itself, so equals to 0. So if we perform FOIL here first, we'll be having v squared z dz outer, we have vz squared dv inner, we have plus 2v squared dz, and last we have 2vz dv. Okay, we perform FOIL. How about in this? So we simply, okay, distribute this, negative 2vz minus v dv is equal now to 0. Okay, so let's combine dz and dv. So we have b squared z dz. Let's find another dz here, which is this, plus 2v squared dz. Okay, that is this one and this one. And of course, as we can see here, okay, of course, this has dv, okay, in it, I forgot. So, dz, and we're going now to dv, vz squared dv, this is that term, okay, plus 2vz dv, this is that term, minus 2vz dv minus v dv is equals to 0. So, you can see here, we can simplify this. This would cancel out, okay, and we are left with this. Okay, v squared z dz plus 2v squared dz, okay, plus vz squared dv minus v dv is equals to 0. So I can factor out v squared, factor it out, okay, and factor also the dz here. So we have a z plus 2 times dz plus, and in this, in dv, I can factor out both dv and the variable v, okay, such that I have z squared minus 1 dv is equals to 0. Okay, and if I'm going to divide both sides of the equation by 1 over v squared, you know what will happen. This would cancel, so we are left with z plus 2 dz in here plus z squared minus 1 over v, because we have v over v squared is v, okay, and we have dv is equals to 0 here. Okay, this can be solved by variable separable. Okay, let me just rewrite this, z squared minus 1 over v dv plus z plus 2, we have dz is equals to 0. A variable separable, we have z squared minus 1 over z, okay, I mean z squared, so we have dv over v. If we multiply this both sides by z squared over 1 or minus 1, so 1 over z squared minus 1, so what will happen? We have dv over v here plus z plus 2 over z squared minus 1 dz is equals to 0. And the next thing to do, the favorite part, okay, we have integral, okay, we integrate both sides of the equation. So simply this is ln of v, okay, but this is integration by partial fractions. So what are we going to do is to integrate this by partial fractions, and we can rewrite this z plus 2 over z plus 1, if we factor the denominator z plus 1 multiplied by z minus 1, since it does not have any squared in here, so we have the coefficients a over z plus 1 plus b over z minus 1. So if we're going to multiply both sides of the equation by z plus 1 multiplied by z minus 1, so what will happen? Okay, so what will happen? We have z plus 2 here is equal now to a times z minus 1. This is only a review of your integration by partial fractions. So z plus 1 here. So if to find a and b, we let some value of z. Okay, let z is equals to 1. So what will happen? 1 plus 2 here, a times 1 minus 1, which is simply equal to 0 plus b. And we have here 1 plus 1. Okay, so we have 3 is equals to b times 2. Or b is simply equal to 3 halves. So we get now the value of b. How about for a? If we let, okay, z equal to negative 1, so what will happen? We have negative 1 plus 2 is equal now to a times negative 1 minus 1, okay, z minus 1, plus b, negative 1 plus 1. As you can see, the b will cancel here. So we have 1 here, and we have negative 2a here, and the value of our a is now negative 1 half. So if we're going to put this back to our okay, so our ln of b, okay, plus, okay, the integral of this, the integral of negative 1 half, which is the a, over, that's the a here, over z plus 1, z plus 1 dz, plus the integral of this b, the value of b is 3 halves over z minus 1. Z minus 1 with respect to dz and equal to the integral of 0. So we can factor out negative 1 half outside of the integral sign, and we can now get also this, factor out 3 halves outside of the integral sign, and we have this ln of c. Okay, the integral of this is ln of c. So what will happen is that we have ln of b now minus 1 half ln of absolute value of z plus 1. Okay, that's right, absolute value, it's okay, plus the 3 halves ln z minus 1. Okay, z minus 1, z minus 1, okay, is equal to the ln of c is simply c. Okay, it's okay. It's okay if that's constant. Okay. So if I'm going to multiply, oops, I think you cannot see. Okay, multiply this equation to eliminate 2 by 2. So what will happen is that we have 2 ln of b minus ln of the absolute value of z plus 1 plus 3 ln of z minus 1 is equals to c. Now, you have to recall the properties of natural logarithm. So, if we rearrange it 2 ln v plus 3 ln of z minus 1 is minus ln of z plus 1 is equals to c. If we have an addition in natural logarithm, we can multiply them. Okay? We can multiply their inside natural logarithm. But whenever we have a constant here, we can use it. We can write this as this. This would be the exponent of the inside function of the natural logarithm. So we have ln b squared. So the 2 becomes the exponent, as well as here, ln of z minus 1 cube minus, we have ln z plus 1 is equals to c. Okay, so what will happen here is that by properties of natural logarithm, if this is a plus, the inside function we will multiply b squared multiplied by z minus 1 cube. And if this is a minus, this is divided by the z plus 1. The inside function of the natural logarithm is now equal to c. So, hi. So what will happen? Let me just rewrite. We have b squared multiplied by z minus 1 cube over z plus 1 is equals to c. So if I'm going to cross multiply this v squared times z minus 1 cube multiplied by C times Z plus 1. Okay, we need to substitute the variables back to its original form. So if you may recall, again, a while ago, that we let U is equals to Vz. But there is a problem here. We cannot simply have any Vz here. We cannot simply substitute U here because there is no Vz here. So what are we going to do is we're going to make a way to have Vz, okay, in order for us to substitute it back to U. So we can actually perform the expansion of this, but I'd rather not to. So there's a technique. If I'm going to multiply this both sides by V over V, this side, okay, by V over V, so what will happen? This is still equal to 1. So multiplying this V over V into this left side of the equation won't affect the equation. So we have V squared Z minus 1 cube is equal to, say, C times Z plus 1. So what will happen is this would become V cube Z minus 1 cube over V. Okay, as you can notice here, that is still equal to this. This is still equal to this because this would cancel, leaving with the V squared. So we have C Z plus 1. Okay, and if I'm going to cross multiply V here, so I have V cube Z minus 1 cube is equals to C times Vz, okay, plus V. So what will happen? By properties of exponent, I can rewrite this as V, okay, multiplied by Z minus 1 raised to 3, okay, is equals to C Vz plus V. So this can be rewritten as Vz, so distribute this V inside this, Vz minus V is raised to cube is equal now to C times Vz plus V. So what will happen here? We already have the Vz. Yes, we can substitute it back. So we have U minus V cube is equal to C U plus V. Okay? But take note, that is not the original variable that we use. Okay? We perform two substitution. Okay, if you may recall, our x is equal to U plus 2. Our y is equal to V plus 1 a while ago. So, we're going to substitute it back to its original variable x and y. So, I can get U and V. So, U here would be x minus 2. And V here would be y minus 1. So, substituting it back. So, U is x minus 2. Okay, that's the U minus the V, which is y minus 1 raised to 3 is equal now to C. Your U is x minus 2 plus V, which is y minus 1. Okay, so upon simplifying, we have x minus 2 minus y plus 1. Okay, because this is a minus distributed with a negative sign plus 1 cube C. Negative 2 minus 1 is negative 3. So we have x plus y minus 3 here on the right side. And if we simplify this, this should be x minus y. Okay. Negative 2 plus 1 would be negative 1. Cube is equal to C times x plus y minus 3. And this is the solution for our given differential equation. So let's try to solve another problem. This would be our last problem. Okay, and the second case. Okay, what if we are asked to solve for the 2x plus 3y minus 1 dx plus 2x plus 3y plus 2 dy. Now notice that our lines here, 2x plus 3y minus 1 and 2x plus 3y plus 2, are parallel. So 2x plus 3y minus 1 is equal to 0. 2x plus 3y plus 2 is equal to 0. You notice that our a sub 1 and a sub 2 are equal. B sub 1 and B sub 2 are equal, whereas our C are not equal. But we can conclude if they are equal in A and B, therefore they are parallel lines and they will never intersect. So, again, we're going to use the second equation, okay, that I've given you a while ago, second substitution. Therefore, our B Okay, our v should be ax plus by. And in this case, what's the value of our a and b? We have 2x plus 3y. Okay? And again, 2x plus 3y, we're going to get a derivative of that. V is equal to 2x plus 3y. Okay? Derive this or differentiate this with respect to v, that is dv. Differentiate this with respect to x, that is 2dx. With respect to y, plus 3 dy. So this is our substitution that we're going to use in solving this differential equation. So what are we going to do next is simply substitute this value on our given differential equation. So 2x plus 3y would now become v. Okay? So this would become v minus 1. Simply, this term is v minus 1 because 2x plus 3y is v. How about dx? So we're going to get dx from our second equation. So the dx would be, okay, deriving dx here. So we have dv minus 3 dy over 2. So our dx would be dv minus 3 dy over 2. Okay? Plus 2x plus 3y again is simply equal to v. And we have plus 2. And we can retain the dy here is equals to 0. So we have reduced the given differential equation in terms of v and y. Okay? So in terms of only one variable v. Okay? So let's try to solve this. Okay? Let's try to solve. So what will happen is that if we multiply both sides by 2, we'll be having v minus 1 times dv minus 3 dy times plus 2 times v plus 2 dy is equal to 0. So if we perform FOIL, we have v dv, that's first, outer, negative 3v dy, inner, negative dv, and last we have plus 3 dy, and in here we have 2v dy, distribute this, 2v times dy, that's 2v dy, 2 times 2 is 4, plus 4 dy is equals to 0 in here. Okay? So combine the dv's and dy, so we have v dv minus dv, here it is, and here. Okay? I can get this first in terms of dy, 3 dy, okay, minus 3v dy, that is that term, plus 2v dy plus 4 dy is equals to 0. Okay? And we can simplify 3 dy, 4 dy. Okay? If we add plus 3 dy plus 4 dy, that's simply 7 dy. Okay? Minus 3v. Okay, this also. Negative 3v dy plus 2v dy is negative v dy. So, negative v dy is equals to 0. Factor out dv's and dy. So, we have v minus 1. We have dv here. Plus, okay, or I can factor out the negative sign in here so that I would be making this v a positive 1. So, if I'm going to factor that, negative, so I have v, okay, minus 7 dy is equals to 0. So, I'd only factor out negative here so that the v here, when we perform this, should be positive. Okay? So, okay, so what will happen here is we're going to separate the variables. We have v minus 1 dv. So we want all the v's in this term over v minus 7 minus dy is equals to 0. So if we're going to integrate this, integrate both sides of the equation, what will happen is that, let me just utilize this small space here because we don't have space. Okay. So what will happen is that we have, I can rewrite this integral, okay, by v over v minus 7 dv. I can separate the numerators, not the denominators, okay, minus the integral of dv over v minus 7. So this whole term is simply the v minus 1 over v minus 7 minus the integral of dy is y, and the integral of 0 is c, okay? So, how do we integrate this? Okay? So, to integrate this, we must make the numerator become the denominator. We must make the numerator look like the denominator. So, I'm going to write this as v minus 7 plus 7 over v minus 7. So, as you can see here, v minus 7 plus 7 is still v. Okay? So, I've done nothing wrong with it because it's still basically equal to v over v minus 7. So, but that is one of the integral techniques, okay, in order for you to integrate this. So, integral of dv over v minus 7, okay, let's just rewrite that, minus y is equals to c. So, I can again separate the integral of v minus 7, the numerator v minus 7 dv, minus or plus, factoring out outside the integral, the 7. So we have dv over v minus 7. I hope you get this part. We just split the numerator and factor out 7, positive 7, outside of the integral sign. So we have the integral of dv over v minus 7 is ln, okay, v minus 7 minus y is equals to c. So as you can see here, v minus 7 over v minus 7, the integral of v minus 7 over v minus 7 is simply dv plus a 7 integral of dv v minus 7 minus ln v minus 7 minus y is equals to c. So integrate this, we have v plus, again, 7 ln of v minus 7 minus ln v minus 7 minus y is equals to c. Okay? And we can simplify this 7 ln v minus 7 minus ln v minus 7 to simply v plus, we have 6 ln v minus 7 minus y is equals to c. Okay? So what will happen if I'm going to rearrange it? I can transpose this onto the right side of our equation. Okay? And transpose c on the left side. So we have v minus y. Transposing c on the left side would not affect its sign. Positive, negative constant, that is still a constant, is equal to negative 6 ln v minus 7. And again, we're going to substitute the original variable back. Okay, so let's remember that v is equal to 2x plus 3y. Okay, that is our substitution. So we substitute it back. So we have 2x plus 3y for our v here, minus y plus c is equal to negative 6 ln of v, 2x plus 3y, that's the v, minus 7. So we can simplify this as 2x plus 2y plus c is now equal to negative 6 ln of 2x plus 3y minus 7. And this is our solution for the differential equation given for our second example. So now I want you to solve some problems, okay? And this is for you. This is a practice for you. You can solve this at home. 2x minus y dx plus 4x plus y minus 6 dy is equals to 0. And the answer, okay, the answer here, let me just write this in red so that you would verify your answer. The answer is x plus y minus 3 cubed is equal to c times 2x plus y minus 4 squared. This is 2x plus y minus 4 squared. So 2x plus y minus 4 squared. So, and that's all for today. Thank you so much for listening, and I hope you learned something from this video. Thank you so much. This is again Engineer Abat. God bless you all.